Morning. Our next topic is solving limits analytically. So we are going to do our best to kind of list all the ways we can solve a limit without a picture, without plugging it into a table in our calculator. So the first, always, the first method you want to try is direct substitution. So before we try anything else, the easiest way to solve a limit is, well, maybe just plug in the number and see what happens. So like here, sometimes we think, oh, special trig limits, we've got to do something interesting here. No, we don't. We're just going to plug and chug. So we're going to take this 0, right, and plug it in for x. So we call this plug in chug, right? And always try this first because it's the simplest. Before you do anything else, you're going to want to do this first. So here we go. We're just going to plug it in. We can say that's equal to 3 cosine of 0 all over 1 plus sine of 0. And you guys remember, cosine of 0 is 1, so the top is 3. And sine of 0 is 0, so the bottom is 1. So we just get 3 and we're done. So that was super fast, right? 30 seconds and we're done. Now, the next 3 or 4 methods kind of depends on what type of problem you're given. So one of the big methods we use is factoring. So if you're given, a polynomial on top and a polynomial on bottom, a lot of times if you've got some sort of limit here, limit as x approaches let's say d, some number d, and you've got some polynomial, so ax squared minus bx plus c, say, and then you've got x minus d. What happens usually with these factoring ones is if you factor the top, usually one of your factors is going to be this x minus d. Okay, so what happens is you try the plug and chug. If you plug in d here, you're going to get 0 over 0. Now we have to do something else, right? And usually what happens is this is one of our factors, and then we can cancel it out. So I'm going to say probably a factor. Okay, so let's do it for example here. We've got example 1, the limit as x goes to 5 of x squared plus 2x minus 35 all over x minus 5. And you notice here, okay, if we try plug and chug, we get 25 plus 10, which is 35. 35 minus 35 is 0, and you get 5 minus 5 is 0. So if you get 0 over 0, you know that's an indeterminate form. It tells us nothing, okay? So then you realize, okay, we have to do some other method, and this one is easy to factor. 35 is 7 times 5, right? So you do x plus 7 and x minus 5. And you guys can see, whoa, lo and behold, whoop, whoop, those x minus 5s go away, right? We can cancel those. That's always so fun to cancel something out. Now, when we do the direct substitution here, now we take that 5 and we plug it in for x, and we do not get 0 over 0, that indeterminate form. We get 12. Okay, so that's a really good method. Factoring is awesome. So direct substitution, number 1. Factoring is probably number 2 if you've got a polynomial. Number 3, sometimes you'll see also with a polynomial, you'll see if there's something to be multiplied out. So I'm going to say multiply And simplify is also another way to get rid of that 0 over 0 when you plug in. So let's do, if you've got something that looks like this, the limit, I don't know, as x goes to 0 here, x plus a squared minus b all over x. So what happens is when you plug this in, you'll get a 0 over 0. You'll get that indeterminate form. So what you'll want to do is take this term and you'll multiply it out. And remember, it's not just x squared plus a squared, right? It's got that middle term as well. And then just combine like terms. And then simplify. Okay, so for example, you might have something like this. The limit, this example 2 here. The limit is h goes to 0, 2 plus h squared minus 4 all over h. So you know if you plug in 0 here, then you get 2 squared, which is 4. 4 minus 4 is 0 over 0. So you've got to do something else. So if we multiply this out, we get 4 plus the middle term is 2 times 2h here. So 4h plus h squared minus 4 all over h. The limit as h goes to 0. Okay, and you guys can see the 4 and the 4, yay, that cancels out, right? And you've got, now we've got h plus h squared. We can pull out, we can factor out an h. So 4 plus h. So we combined the like terms, and then we did a quick little factoring, greatest common factor there. And again, lo and behold, that h that's causing this to be 0 over 0, we're going to get rid of that. And now we do the direct substitution, our last step, and we get 4 plus 0, which is 0. 4 plus 0, it's not 0. Oh my goodness. Ha ha ha. 4 plus 0 is 4. Don't make that mistake. All right. And then the last kind of algebraic method that we learned was conjugates. So if you've got something that looks like this, conjugates. If you've got that square root in here, so this is the limit. Can you guys see that? Yep, the limit as x goes to 0, square root of x plus a, plus or minus. Sometimes it's plus, sometimes it's minus, another number, and then all over x, right? So what this is, we have to get rid of this conjugate in the square root. We've got to get rid of that square root, and we do that by multiplying by the conjugate. So the conjugate is the same thing on top. It's going to be root x plus a, but if it was a plus, then it would be a minus, and if it was a minus, then we'd be multiplying by a plus. And what that does, it's like the difference of squares. It gets rid of that middle term. And you guys know you can't just multiply the top of a fraction. You've got to multiply the top and bottom by the same thing, or you'd be changing the problem, and we can't change the problem, right? So now we're just multiplying essentially by 1. Okay, so let's do a quick example for that one. Okay, so example 3 here. You see that? All right. So the limit as x goes to 0, and we're going to do x plus 1 minus 1 all over x. And you guys can see again, we try the direct substitution, and we get 1 minus 1, which is 0 over 0. Okay, so now we're going to multiply by the conjugate, the square root of x plus 1 over the square root of x plus 1 plus 1. So now when we multiply this or FOIL this out, right, we do the first, and we're going to get the limit as x goes to 0. Well, when we multiply The square root times the square root goes away, and we get x plus 1. And then the middle terms are going to cancel, right? Negative root x plus 1 and a positive root x plus 1, those go away. And then we get negative 1 times a positive 1 is minus 1. And then the bottom, I just leave it. It's not pretty, but I just leave it. Okay? And then what happens, positive 1 and minus 1, we can cross those out, right? We combine like terms, and now we've got the limit as x goes to 0. Can you see that? Yeah. X on top, x times root x plus 1 plus 1. And now x on top, x on bottom, that goes away. And remember, you don't have 0 here. What do we have? Yep, you're right. We have a 1. So it's the limit as x goes to 0, 1 over root x plus 1 plus 1. And now we plug in 0 and we get 1/2.